So hello everyone. So today we are going to solve the problem of the 4th February 2026, which is Trionic array 2. This is a hard problem. So this is what the problem is asking us to do. You are given an integer array nums of length n. We have a definition of Trionic subarray. So a Trionic subarray has a shape of three segments. For example, from L to P, our segment should be strictly increasing. Then from P to Q, our segment should be strictly decreasing. Then from Q to R, our segment should be strictly decreasing. In our array nums, we may have multiple Trionic subarrays. We need to return the maximum sum of any Trionic subarray in nums. This is what the problem is asking us to do. In this video, we will try to solve the problem using a greedy solution, and in the next video, we will try to solve the same problem using another approach, which is dynamic programming. So let's start. So how we are going to approach our problem using this is the first solution, which is greedy. So at the end, we need to return the maximum sum of any Trionic subarray. So we will represent it as a variable called res. And since we need to maximize it, so we initiate it to minus infinity. And whenever we find a Trionic subarray that has a sum bigger than res, then we update it. Okay, now for the how we are going to check if to get the sum of how we are going to get a sum of Trionic subarray whenever we find it. For this, we will use two pointers. The first one will start from 0, we call it I, and the second one, which is I plus 1. And this second pointer, for the first segment should be increasing. We will keep increment it whenever nums of j is bigger than nums of j minus 1. It means our first segment keeps increasing at indices starting from G. That's it. So the index P will be equal to J minus 1. And from E to G to P, our first segment, as we said, it has an increasing order. And for the sum for the first segment, how we are going to calculate it? So if we do a small observation, let's imagine, for example, that our segment has our first segment, which is increasing, has a length, for example, 3 or 4 or 5 or whatever. So, for example, the index here is minus the value corresponding to index 0 is minus 3, and this if we take in consideration this value, it may lead to a to a smaller sum. So in that case, for example, we can just in the first segment we can just take this point, this value corresponding to index p, and the first one and the previous one corresponding to index p minus one. And we are not sure yet if we should include the rest of points or not. So for this, our current Trionic subarray sum, we will add to it the value corresponding to index p and the index p minus one. And for the rest of points, later on, we will use two variable accumulative sum, and which we will loop from index p minus 2 to 0, and we will keep adding the values corresponding to these indexes to accumulate to our cumulative sum. And another variable, which is, we call it mx, which is the maximum between accumulative and mx. Then our sum of our current Trionic subarray, we will increment it the value of mx. We will we'll add to it the value of mx. This is how we are going to approach the first segment. And for the second segment, okay, and we need to check we need to check if the difference between, if p equal to e, then the length of the first segment, which should be increasing, is zero. So there is no an increasing segment at this starting from I. Then the first pointer should be incremented to 1. And for the second segment, we will keep incrementing our second pointer, while nums of j is lower than nums of g minus 1. That's it. And for and our current sum, we always we will increment to our current sum the value of nums de g. And for the so q will be equal to g minus 1. Also, we need to do the same thing as to check if q equal to p. This means that that the length of the second segment that should be decreasing is 0. So there is no decreasing second segment. So in that case, we need to move forward I to q. So we do not satisfy the shape of Trionic. We do not satisfy the Trionic shape. And for the last third segment, we will do the same thing that we did in the first segment. We will add. We will keep increasing g, which is the second pointer, while it's lower than its previous one. And we want to directly add the value corresponding to nums de g to our current sum. We will do the same thing. We will add the value of nums de g to our variable, which is cumulative sum, and mx will take the maximum between the cumulative sum and mx, and then we will add mx to our current sum. That's it. and the sum. That's it. How we calculate the sum of our Trionic subarray, and then we will update I to Q. We will update I to Q since we know that the third segment is increasing, and the Trionic subarrays start from an increasing segment. So we will add I to Q. We will increment I to Q in order to check if there is another Trionic subarray, and we will calculate its current sum, and we will and if the current sum is bigger than the res, then we update the current we update res to value of the current sum, etc. And then and finally at the end we will return res. This is the overall the idea, the general idea. This is already solution, and let's try to write it and to understand it better. So let's start writing our solution. As we said, we have a first pointer, which is I. So while I is lower than lambda nums, our first pointer I starts from 0. And we have J is equal to I plus 1. And while J is lower than la of nums, our second pointer is lower than lambda nums, and nums of J is bigger than nums of J minus 1. This means that our first segment is keeps increasing. So in that case, we increment G plus equal to 1. That's it. And our so the point P, the P index will be equal to G minus 1. P equal to G minus 1, and we need to check if P equal to I. This means that the length of our first segment, which should be increasing, is 0. So there is we do not satisfy the Trionic shape, so we increment I to 1. That's it. So if P equal to I, in that case, I will be plus equal to 1. And initially, our current sum will be equal to nums of P plus nums of P minus 1. Later on, we will check the rest of values yeah, if maybe they lead to a bigger sum. And for the second segment should satisfy the decreasing order. So this is our second pointer G, while it's lower than nums, and nums of G is lower than nums of J minus 1. In that case, we add nums de G to our current sum, current plus equal to nums of G, and we increment our G plus equal to 1. And we need to check. So the Q index will be equal to G minus 1, and we need to check if P equal to Q. This means that the length of the second segment that should be decreasing is 0. So in that case, we move forward I to Q. If P equal to Q, in that case, EI equal to Q. Then continue. We forgot here to write continue. So this is this is our second segment sum, and this is our first segment sum. First segment sum. We forgot to initialize the raise, which is minus infinity, and whenever we find curve, which is our the sum of Trionic subarray lower bigger is bigger than the raise, then we will update this. Okay, let's so here curve plus equal of nums to g and g plus equal to 1. Then we have our cumulative sum equal to 0 and mx equal to 0. Here just we need to check also if p equal to q, or q equal to la of nums minus 1. So we have reached there is no enough points for another segment that should be decreasing, or nums of q equal of nums of g. And for the for the sum of the third segment, while g is lower than lambda nums, and nums of g the third segment strictly increasing is bigger than nums of g minus 1, then our cumulative sum plus equal to nums of g and mx equal to max between mx and our cumulative sum. And we will add to our sum of Trionic subarray, which is curve plus equal mx. That's it. Now let's go back to our first segment. As we said, we just added to our sum to the sum of the first segment the last two indices of the segment, and not and not the full segment, since we are still not sure, like we are still not sure if, for example, let's take this first segment has a length 5 or 4, maybe the previous points lead to a lower sum. So we will go back now and check that. Just here we forgot to increment g to plus equal to 1, and now let's call gg equal to p minus 2, and we will loop while gg is lower than 0, z bigger than 0, and nums of gg, the first segment we said should be increasing, so nums of gg is lower than nums of gg plus 1, then in that case our cumulative sum, let's initialize it with mx equal to 0 and mx equal to 0. So we will increment nums of gg to our cumulative sum plus equal nums of gg and mx equal to max between our cumulative sum and mx on g plus equal to 1. That's it. And we will add to our current sum the value of mx plus equal to mx. And finally, we will update whenever we find a new sum of a Trionic subarray. We will check if it's bigger than res or not. So res equal to max between res and cur. And we will update the first pointer to q. As we said, since the last segment is increasing and the first segment is increasing, so we move I to q. And finally, we return res. Return res. That's it. I think this time limit exceeded. What is the issue here? Maybe there is some g is not g. Okay, here we keep incrementing g. G also here keeps incrementing. We keep incrementing g. Here first of all we are doing a reverse loop, so minus equal to 1 and the variable name is gg and not g. This is really nice to time limit exceed. And that's it. So in the next video we will try to to save to solve the same problem using another approach, which is dynamic programming. And hope you liked the video. Bye bye.